Now we're going to apply the information I talked to you about in the previous video. And the reason I put so much emphasis and time into that one is because when you look at this, if the tangent of theta is equal to a half, just because it's equal to a half, I don't have to worry about the size of this triangle whatsoever. The tangent of theta will always equal a half no matter what the size of that triangle is, whether make it a big triangle or small triangle based on the idea of similar triangles. So what we can do then is we can take this tangent of theta equals a half, and we can use that information to help us find the other five trig ratios. So tangent of theta is loaded with information. Remember that the tangent of theta is defined to be the side that is opposite over the side that's adjacent. So we declare one of these angles to be theta, and I think in this picture it would make more sense if I put theta here. The length of 1 here is the opposite side, and the length of the adjacent side is 2, put that there. If I use that, then I've got to be able to figure out how to find our other missing side, and since we're working with right triangle trigonometry, that is a right angle. So that's not too big of a push for us because we can use our Pythagorean theorem in a right triangle. So we've got our two legs, 2 and 1, so 1 squared plus 2 squared has to equal our hypotenuse squared. I'll use c for that. So we got 1 plus 4 equals c squared. So the length of c has to equal the square root of 5. Now technically it's plus or minus, but I only want the positive because we're dealing with the length of the side of a triangle. So square root of 5. And I'm going to clean that up and make sure that that's a little bit more visible. This is the square root of 5. After we have that in place, in order to get the sine, cosine, and tangent, and the other three, we're just going to apply our definitions. The sine of theta is the opposite, which is 1 over the square root of 5. I want to rationalize that, so it's going to be square root of 5 over 5. The cosine of theta is the adjacent side, which is 2. So it's 2 over the square root of 5. Again, rationalize, it's going to be 2 times square root of 5 over 5. The tangent of theta is, and what they told us at the beginning, is a half. So now what we can do is we can apply our reciprocal ideas. I can go back and refer back to the triangle. If I want to know and go back to our cosecant, it's always going to be the hypotenuse, which is 2, over the opposite side, which is 1. Or if I take the reciprocal of this beginning one, it's going to be the square root of 5 over 1, or just the square root of 5. The secant is always the hypotenuse over the adjacent. So I could go back and say, well, that's the hypotenuse over the adjacent, which is 2, or square root of 5 over 2. If you see, if I go back to my original cosine, if I just reciprocate it, I got square root of 5 over 2. And find the cotangent is going to be the reciprocal of tangent, which is 2 over 1. Or if you want to think of it, it's always the adjacent side, which is 2, over the opposite side, which is 1, or just write it as 2. So all you got to do is use your information that you're provided, use that to write some numbers on your triangle. I'd always get a visual on that so you can see your sides. Use your Pythagorean theorem to find the missing side, and then go through your definitions and apply those to find the remaining 5 trig ratios. So pretty simple task to do for us there.